Okay, 2.3. 2.2 is solving one-step equations. 2.3 is all about solving multi-step equations. Multi means more than one. So it could be 2 steps, could be 3 steps, could be more. Any of those could fall under multi-step equations. Let's get into it. A multi-step equation is an equation that uses more than one property of equality to solve it. The properties of equalities that it's talking about is our addition, subtraction, multiplication, division properties of equality that we talked about when we did 2.2 notes. Whatever I do to one side, got to do to the other. That's our properties of equality. If I add one thing to one side, I got to add the same thing to the other. Same thing with subtraction, multiplication, division. So, to solve this type of equation, you can undo each operation using properties of equality, just like we did with the one-step equations. Whatever I do to one side, got to do to the other. Working backwards in the order of operations makes this process simpler. I'm going to preface this by saying most of the time. It's not always the exact reverse of the order of operations, and we'll look at some examples like that here in a second. Each step in this process results in equivalent equations. Equivalent equations. So we've already talked about our inverse operations, or our opposite operations. Inverse of addition is subtraction. Inverse of subtraction, addition. Inverse of multiplication, division. Inverse of division, multiplication. Are we okay knowing what the inverse operations are at least? Okay. Any questions about anything we just covered?
No.
Before we jump into some examples.
Yeah.
All right. Okay, use properties of equality to solve each equation. Check your solutions. So, letter A, we've got 2a minus 6 equals 4. So, on the previous slide, it told us to kind of do the reverse of the order of operations. So here, we've got 2 times a minus 6 equals 4, correct?
Right.
So, usually what would come first? Multiplication or subtraction? Multiplication. In this case, I'm going to actually do the subtraction part first. It's 2a minus 6. What's the inverse of subtraction? Addition. So I'm going to deal with this 6 first. It's a minus 6, so I need to add 6 in order for it to cancel out. Because negative 6 plus 6 gives me 0. And I'm dealing on the left side of my equation because that's where my variable is. What's my goal?
Isolate the variable.
Isolate the variable. Get the variable by itself on one side of the equation. So I've got to move numbers away from the variable. So I'm starting with this 6. Whatever I do to one side, got to do to the other. So I got to add 6 to 4 over here as well on the right side of the equation. We okay with that first step that I'm almost done with? After the 6's cancel on the left, what do I have left over on the left side of the equation? 2a. Equals, and then on the right side, what's 4 plus 6? 10. You okay with that first step that is now completed? Okay. Now, I've gotten rid of that 6. What else is on the same side of the equation as a? What number? 2. Some of y'all have already said it. It's being multiplied by a. What's the inverse of multiplication? Division. So I've got to divide by 2 in order to cancel it out. You okay with that? Whatever I do to the left, got to do the right as well. Oops. After the 2's cancel out on the left, what's left on the left-hand side?
10 divided by 2.
A. Thanks for listening to the question that I asked.
You're welcome.
On the right side, what's 10 divided by 2? 5. Is my variable now isolated by itself on one side of the equal sign? Yep. So a equals 5 is my solution. We okay with that?
Oh, yeah.
It tells me to check our solutions. I'll just do it real quick. To check our solution, we can plug our answer back into the original problem. Using the order of operations on the left, what's 2 times 5? 10. Just working down both sides of the equal sign. What's 10 minus 6? 4. Does 4 equal 4? Yep. So my answer checks out. I know my answer is correct because I plugged it in and I got a true statement back. Questions on example 1A? All right. Letter B. N plus 1 divided by negative 2 equals 15. What do you guys think we need to do first? So, this is one of those examples where I don't like them saying that you do the reverse of the order of operations. Because I am not able to subtract 1 first here. Okay, because my whole numerator is, well, the whole left side of my equation is written as a fraction. So I've got to get rid of that denominator before I can do anything with the numerator. Okay? A fraction is just what?
Division.
Division. So this is n plus 1 divided by negative 2, correct? What's the inverse of division?
Multiplication.
Multiplication. So what could I do to get rid of this negative 2?
Negative 2 times n.
I can multiply this left side of the equation by negative 2. That's going to cancel out my denominator. Okay? Whatever I do to the left, got to do to the right. So after the negative 2's cancel, what's all that I'm left with on the left?
N plus 1.
Just that numerator, n plus 1, right? Any questions how I got that? Right side, what's 15 times negative 2? Negative 30. Now, what number is also on the same side of the equation as n? 1. It's n plus 1. What would I have to do to cancel out this 1? Subtract 1. Whatever I do to the left, got to do to the right. Left-hand side of the equation, 1's cancel out. What am I left with on the left? N. On the right side, negative 30 minus 1 gives me negative 31. Is n now by itself? Yep. There's my answer. We okay with that? Checking my solution. Negative 31 plus 1 over negative 2 equals 15. What's negative 31 plus 1? Negative 30. What's negative 30 divided by negative 2? Positive 15, which is a true statement. I know my answer checks out. Any questions on example 1, A or B? After 2 examples, how do we feel about multi-step equations so far? Okay, some of us are not great, but okay. Okay, can I move on? Word problem. The student council raised 2/5 of the money they need to cover the cost of the school dance with a bake sale. They raised an additional $150 selling raffle tickets. If the student council has raised $630, what is the cost of the dance? Write an equation for the problem, then solve the equation. So, what's all the information that I know here? What? Actually, first, let's talk about our unknown. What's my unknown? What am I trying to find here?
How much the tickets cost?
Cost of the whole dance. Not the tickets, but the cost of the whole dance. Right? So, what is the cost of the dance? That's my unknown. The book, I believe, gives it a variable of C to represent the cost. If you were doing this problem on your own, you would be able to pick your own variable because they do not give you a specific variable to use. But we're going to go ahead and use C since that's what the book uses. We okay with that?
Yes, sir.
C equals cost of dance. That's my unknown. That's what I'm trying to find. Okay, what's some information that I do know? What are my knowns?
They're selling raffle tickets
The
or they
money.
raised it
Yeah, how much did they raise selling raffle tickets?
$150.
They raised $150 selling raffle tickets. What else do I know?
Student
They raised
council
like
raised
$630.
$630.
Yep, they've already raised $630 total
Whoa.
from the raffle tickets and the bake sale. Correct?
Mhm.
What's the last bit of information I know?
The student council raised 2/5 of the money they needed to cover.
They've raised 2/5 of the money with the bake sale. Right? 2/5 they need to cover the cost of the dance with the bake sale. So, knowing my knowns and my unknown here is being represented as C, how could I put that all into an equation to represent the problem here? Any ideas? Want to take a shot at it? I hear you saying it. I heard you say 2/5.
Plus,
Hold on.
Yeah.
Okay.
Times it.
no.
What do we use?
Times C.
Times C. It's 2/5 C.
150 equals
630.
630. Very good.
Yes.
We know they've raised a total of $630 so far, so that's going to be equal 30. 2/5 of the money they need. The money they need is C. So 2/5 of C. Plus they've raised $150 selling raffle tickets. So 2/5 of the cost they need plus the $150 from raffle tickets equals the total amount that they've raised so far, $630. Are we okay with how we got this equation? Any questions on that? So that's exactly what the book came up with as well. 2/5 C plus 150 equals 630. Now I need to actually solve this equation. So, what two numbers are on the same side of the equal sign as C?
2/5 C.
2/5 and
151.
150. What do you guys think we need to get rid of first? The 150. Okay? It's 2/5 C plus 150. So how do you think I need to cancel out the 150?
Minus.
Subtract 150 from both sides. Whatever I do to one side,
You have to do it up.
got to do the other. So on the left, I have 2/5 C left over. Equals what's 630 minus 150?
480.
What?
480.
480. We okay with that? Questions how I got that so far? Okay, I've got 2/5 C equals 480 now. Raise your hand if you can tell me what I need to do to get C by itself in this case.
I know.
There's two ways you could approach this one. Multiply by. Close. 5
5 over 2.
5 over 2. Yeah. Remember, if I want to, I can multiply a number by its, what do we call that when we flip it? Reciprocal. What happens when I multiply a number by its reciprocal?
0. 1.
You get 1, right? So I could multiply by 5 halves here. That'll cancel out. I have to multiply by 5 halves over here as well. 480 times 5 halves. Someone have a calculator handy on them?
I do.
Not your phone, not your phone. Put your phone away.
I don't.
Do you want to type that in for me? Say it again. 1,200. So the total cost of the school dance is $1,200.
1200.
$1,200. What's another method I could have used to solve this from this point? Division, right? 2/5 is being multiplied by C. Right?
Right.
What's the inverse of multiplication?
Division.
So I could divide by 2/5 on both sides. 480 divided by 2/5 will also give me 1,200. Okay? Any questions on example 2?
No.
We good with that? Can I move on to my last example?
Please.
Yes.
Did someone say no? I'll give you a little more time. Okay. Can I move on? Oh wait, here's my last example. Some equations have coefficients that are represented by letters. We may not know those coefficients, so they just use another letter to represent it. To solve these equations, we still just apply the process of solving equations to isolate the variable. I'm still just using my inverse operations. I'm treating A kind of like a number here. Because that's what it is. A coefficient's a number, right?
Right.
Do I know what that A is?
No.
No. So just when I add it or subtract it or multiply it or divide it across, I won't be able to actually compute that letter plus, minus, times, or divided by another number. So let's see what that looks like here real quick. Solve AX plus 7 equals 5 for X. Assume that A does not equal 0. So, what numbers are on the same side of the equation as X here?
A and
7.
7 and A, right? A is just a coefficient. I just don't know what it is right now. So, I need to get rid of the A and I need to get rid of the 7 to get X by itself. What do you guys think we need to do first?
minus 7.
Yeah, it's AX plus 7. To cancel the 7 out, I'm going to subtract 7. Whatever I do to the left, got to do the right. So 7's cancel out. What's left over on the left-hand side? AX. 5 minus 7 gives me
Negative 2.
-2. We okay with that first step? Any questions or confusion there? Now, I've got AX equals -2. So what's on the same side as X?
A.
A. What's the operation going on between A and X? Multiplication. What's the inverse of multiplication?
Division.
Division. So I could divide by A to cancel it out. Whatever I do to the left, got to do to the right. So on the left-hand side, what do I have? X. Now the right-hand side, I've got -2 divided by A. Do I know what A is? Do I know what A is?
No.
No. So can I compute -2 divided by A? No. So I'm just going to rewrite it as -2 over A. And that's my answer. Because I don't know what A is. Does that make sense?
Yeah.
You just leave it in terms of that variable because I don't know what that variable is. If I knew what A was, I would do -2 divided by that number, and it would give me a number. But I don't know what A is, so I can't calculate that, so I've just got to leave it like this. Be okay with that?
Yeah.
And with A being in the denominator, this is why I said assume that A does not equal 0, because in math, we cannot have 0 in the denominator. So, there you go. Questions on example 3? How are we feeling about multi-step equations? Good?
I love it.
Love it. Good.
I like one step
Huh?
better. I like the one step better.
Yeah, one step's definitely easier, but we're only going to add to this. We're going to get more steps later on. Okay? So, on Canvas, you're looking for 2.3, homework number 1, MH. That's going to be your homework assignment for today. It'll be due Monday, the 30th on Canvas. Okay? Do we have any questions about the notes before I end the recording?